Hello and welcome to the course of HDL Digital Circuit Design. Today's topic is step-by-step guide for implementation of 4-bit up-down counter on hardware. Myself Shilpa Rudrawar, Assistant Professor, School of ENTC Engineering, MIT Academy of Engineering, Anandi, Pune. So in previous session we have gone through what is clock divider because this clock division we'll be using for our counter. Then this is the clock divider circuit. The code for that is also explained. Test bench. Along with that, the code for counter as well as its test bench is explained. And in previous session, the simulation of this counter in Vivado tool has been explained. So now moving ahead with the hardware implementation. For that, you need to create a XDC file that is Xilinx design constraint. And then we will be generating bitstream and then we'll be programming our device, that is the Nexus 4 kit. So this time I'll be using this Nexus 4 kit instead of Nexus 4 DD. So here we are creating XDC file. So as you are able to see here switches, there are 15 inputs, total 16 inputs and 6 output assigned. You can assign over here and the names are also defined here. So in our counter we require 4 outputs, that is counter is of 4-bit. That's why we are assigning this particular pin, that is T6 we have assigned as a counter output high pin or MSB pin. Then this R8 will be assigning as a next bit. Then V9 we are assigning as a counter first bit and T8 we are assigning as a counter 0th pin. So that's why we'll be getting that 0 0 0 0 0 0 0 0 1 like we blinking at this particular pins. Then we need to give clock, which is the system clock we are applying. That's why E3 pin is the that particular pin where the system clock is getting generated, which is a high frequency clock. And this is a clock underscore D where the divided clock you will be able to see. As I want to observe that clock because it will acting as a in and out, but still input is getting generated. That clock underscore D is getting generated through that clock divider circuitry, and that's why we'll not be assigning it as an input pin, but we'll be rather assigning it as an output pin, and that's why we have considered this P2 as an output. So here we'll be getting blinking of that particular clock. So how fast or how slow that clock is operating, that you'll be able to see after it is blinking over here. Mode, that when I am making P3 pin, this is what is the P3 pin, which is acting as a mode pin, which I am making 0, it will be performing down counting, and if the pin is kept as a 1, so it will be performing up counting. And this is the last is the reset pin, which is the P4, which will be used for the resetting the circuit. So this is again, this is what first pin, that is the reset pin. This is the mode pin. This is my clock underscore D output. This is what counter output will be observing on this 4 LEDs. So same file will be creating in our Vivado tool. So this is what is the file we are having. So this is what is the code we have written. The test bench has been written. There is no constraint file created yet, and that's why you need to click on this schematic. So once you are clicking on the schematic, you are able to see this structure, that is how that gate level netlist is getting implemented, and here you are able to see that particular counter pins. So here counter 3 2 1 0, so we'll be by default assigning this as a LV-CMOS 33 because the IO standard is 3.3 voltage, and then same we'll be doing ahead with the all other. So rest of the clock underscore D, reset, every pin will be making LV-CMOS 33. So once that has been done, depending upon whatever XDC file we have discussed now, will be assigning that pins over here. So clock will be assigned E3 pin. Then clock underscore D will be assigned as a P2 pin. Then mode will be assigned to P3 pin, and last reset will be assigned to P4 pin. Now remaining this particular, that is counter of 3, will be assigning to T6 as I have told you earlier where we will be connecting. So that is the T6. Next we'll be having R8. Next will be V9 and counter 0th bit will be assigned to T8. So here we'll be writing T8. Once that has been done, we'll be saving this file with certain name. So this is I have said. Now you are able to see this file is getting created under constraint folder, and you are able to see how it is getting created. So this is the Elvis CMOS 33 for all the pins, and these are the clock pin is assigned to E3. This particular clock underscore D will be seeing output on P2. That way everything is declared. Once that has been done, now you need to go to your source file, check over here that counter will be working on clock underscore D, and that's why you need to divide this clock with the higher value. Otherwise you will not be able to see the transition from 000 to 001, and that's why for that purpose I am making it as a 25. So my clock is getting divided by the 2 raised to power 26 value over there. The reason behind that I already explained in the previous video. You can go through that video. The link of that video will be putting in the description box. So once that has been done, now this clock underscore D is acting as an input clock to this clock divider. Now we'll be clicking on this bit file. I have saved this, and now I'm clicking on generate bitstream. So yes, once that bit file is getting generated, you can dump that bit file into the target device, and you can observe that execution of the 4-bit counter in hardware. So meanwhile, I have connected my hardware to the laptop. This file is getting generated. If some errors are there, you can observe that error in the error window. So running route design is happening now. Design summary, if you want to check, you can check at this point, summation, and you will be able to see what project name you have given, what property is selected, what is the model name, and how many LUTs has been used, as well as IOs pins has been used, what are the flip-flops or buffers available. Everything related to your project you will be getting estimated utilization here. So your right bitstream is getting generated. Once that has been done, you need to click on open hardware over here. Meanwhile, you need to connect your hardware with your laptop. Once that has been done, open target and open new target. Next, that your hardware is getting detected because you have already connected your hardware with your laptop. Once that has been done, you need to program device. This bit file which is getting generated, because of this it is getting pop up here, and you need to program it. Once that has been done, now on the kit you'll be able to see that counter execution. Now in the coming session I'll be uploading the hardware video where I'll be showing you how that counting operation is happening. So thank you everyone for your patience listening, and this is the code as well as execution of counter. So happy learning. Thank you.